What is HMI? HMI, Human-Machine Interface, is a user interface or dashboard that enables humans to engage and interact with machines. HMI provides an intuitive and efficient way for operators to control, monitor, and configure devices and processes. Undoubtedly, it has become an indispensable element in industrial computing to carry out industrial automation processes optimally. Some examples of common human-machine interface devices that we encounter in our daily lives include touchscreens and keyboards. Key features of HMI. Data visualization through the HMI screen. The HMI screen displays essential information in a clear and understandable manner for the operator. Through graphics, diagrams, indicators, and visual alarms, the HMI provides a visual representation of data and the system's status, facilitating real-time decision-making. Control and operation. The HMI enables the operator to interact with the system and control its functioning. Through buttons, virtual switches, sliders, and touchscreens, the user can start, stop, adjust parameters, and perform specific actions as per the process requirements. Configuration and programming. The HMI also offers the ability to configure and program automated devices or systems. With an intuitive interface, users can set reference values, define operational sequences, and customize settings to adapt the system to different requirements and conditions. Diagnosis and maintenance. In addition to everyday operation, the HMI facilitates problem identification and resolution in case of failures or errors. It provides diagnostic tools, event logs, and alarms, allowing technicians to efficiently detect and resolve issues. Remote access. Users can utilize an internet connection to view information about the plant's operations and send control commands to machinery from anywhere in the world. Additionally, they can monitor and control equipment through mobile devices such as smartphones or tablets, enhancing flexibility and enabling quick responsiveness during operations. Security. The system provides tools to restrict access and create user accounts with specific permissions, ensuring that only authorized personnel can access sensitive information. To enhance security, encrypting outgoing transmissions is essential to protect data during transfer. Furthermore, collecting operation logs also helps track operator activity, allowing for the timely detection and handling of unauthorized actions. Types of HMI. Touchscreens. These are HMI that use a touchscreen display to present process data and allow the operator to input commands. The seamless integration of user input and display output offers obvious advantages, as it allows designers to add their controls and relevant data to individual screens tailored for specific needs. Web-based HMI. Web HMIs are client-only interface panels that offer a fresh alternative to traditional HMIs. These are HMI that use a web browser to present process data and allow the operator to input commands. Designed with simplicity and security in mind, web HMIs do not store or process data locally, relying on a centralized server to perform these tasks instead. Physical control panels. These are physical HMI that use buttons, switches, and displays to present process data and allow the operator to input commands. They are often used in industrial settings, where a GUI or touchscreen may not be practical, such as in environments with high levels of vibration or dust. Headless HMIs. While most HMIs come equipped with a built-in screen and user interface, there are a few reasons why this may not be desirable. The headless HMI eliminates the screen and enables users to send video out through HDMI or network connection instead. Doing so greatly reduces the size of the unit and allows the HMI processing and communication hardware to fit into tight enclosures or mobile stations, where space is at a premium. Key components of HMI systems. Hardware. Hardware includes the physical parts you can touch, such as the screen, keyboard, and computer processor. Input devices, such as touchscreens and buttons, allow you to give commands to the machine. Output devices, such as monitors and speakers, show you what the machine is doing visually or audibly. The processor acts as the brain of the system, handling all the commands and running the software. Software. The software is an HMI program used for screen interaction, facilitating machine operation and data visualization through functional buttons, sliders, or charts. It also provides performance insights, reflecting how well the machine is functioning and identifying areas that require improvement. Communication. Communication and connectivity mechanisms are how the HMI system interacts with machines, achieved through wired connections like Ethernet networks or wireless options such as Wi-Fi. Advantages of human-machine interface. Improved efficiency. HMI allows operators to easily access process data and input commands, which can improve the efficiency of the process being controlled. By presenting data in a clear and concise manner, operators can make more informed decisions and take timely action when necessary. Real-time monitoring and analysis. An HMI screen is required to provide real-time visualization of system data and parameters, enabling operators to monitor performance and detect any abnormalities or deviations. Intuitive and user-friendly interface. HMI devices are designed with a focus on user-friendliness and intuitiveness, featuring capacitive touchscreens and visually appealing graphical interfaces to facilitate seamless and natural interaction with the system. For personnel less adept at adapting to technology, the benefits of HMI touchscreens are significant, enabling quick acclimation to processes and enhancing work efficiency. Versatile connectivity and compatibility. These advanced devices offer a wide range of connectivity options, allowing integration with various systems and peripheral devices. They can connect to industrial networks, communicate with PLCs, and other automation equipment. Disadvantages of HMI. Dependence on HMI systems. If the HMI stops working or is unavailable, operators may not be able to access critical data or control the process, which can disrupt operations. Potential for human error. Operators can make mistakes when using HMI, such as inputting incorrect commands or failing to notice an alarm. This can lead to problems with the process being controlled. Additional cost. Implementing an HMI can be an additional cost, as it requires the purchase and installation of the HMI itself, as well as any associated hardware and software. Some common applications of HMI include manufacturing. HMI is commonly used in manufacturing settings to control and monitor production processes. They can be used to present process data to operators, allow them to input commands and set points, and present alarms and other important information. Power generation. HMI is also used in power generation plants, such as those that use fossil fuels or renewable energy sources, to monitor and control processes such as boiler operation, turbine control, and electrical generation and distribution. Water and wastewater treatment. HMI is used in water and wastewater treatment plants to control and monitor processes such as pumping, treatment, and distribution. Oil and gas. HMI are used in oil and gas production and refining to control and monitor processes such as drilling, pumping, and refining. Chemical processing. HMI is used in chemical processing plants to control and monitor processes such as mixing, reaction, and distillation.